Welcome everyone. Today we have our another new episode and we will discuss on AI in the deep sea tech. We have our world famous speaker, Professor David Smith. My first questions to Professor David Smith: how can AI be integrated into the deep sea technology to enhance underwater explorations and research?
Well, Sharif, the answer is in many, many different places. We know more about the moon than we do our deep oceans. So that's part of where we're going. And we've always looked outward as opposed to inward to understand them. And, the overall view of looking at deep sea technology and its use of AI combines really cutting edge advancements in robotics, in artificial intelligence, in vision systems, and image recognition, and all of them to really explore the mysteries and the business opportunities and the ability to help uh, protect our planet in some really intriguing ways. Researchers have for many years began to look at and demonstrate how autonomous robots and AI can dramatically accelerate the exploration study of hard to reach deep space ecosystems. And, by leveraging AI and machine learning and vision recognition, we can identify really critical links between the world's oceans. And the oceans provide over 90% of the living space on Earth. It regulates weathering patterns, it captures carbon, absorbs heat from the atmosphere. And in reality, the deep sea technology in the ocean sustain billions of people worldwide. And we've seen that as we see some of it. The other place that we're seeing AI employed today in the oceans is helping us look at trade stability and geopolitics, particularly in the Red Sea area today. We've had decades of relative peace and stability on our international waters, but we're today in a place where some of the key maritime ocean routes are being held hostage by violent attacks. And we're seeing more and more AI being used to help mitigate some of those and being used, as well as international political pressure, as well as military pressure. And we're about to have the World Trade Organization 13th uh, conference. And part of what's going there is there's a $9 trillion opportunity going to be discussed there on how to digitize trade based around artificial intelligence and the maritime interfaces. And we're seeing it in the ability to work in these areas with AI in many, many different places. And if I just look at AI by itself, the market has been witnessing remarkable growth. In 2023, the market size was about $197 billion, and it's expected to expand with an annual growth rate of about 37% to 2030. And we see them in all different areas. We know we've talked about how the AI market is hardware, software, services with many different technologies, and uh, how it's being used and how we have access to it. But the deep sea mining technology market by itself, which combines the cutting edge advances, like I said before, in robotics and artificial intelligence, is really growing too. In 2020, the global market for this deep sea mining was about 650 million. It's projected to be over $15 billion by 2030. So as we look at this and how the AI in the deep sea is uh, technologies are being combined, we're seeing them that some things like the deep sea mining involves extracting minerals and metals from the ocean floor, sometimes at depths running from about 200 meters down to 6,500 meters. And these minerals include things like copper, cobalt, nickel, and one that we're having difficulty finding more and more all the time is some of the rare earth elements. And these resources are critical for the production of a lot of technologies like electric vehicles, batteries, other green innovation. And, while the deep sea mining, the deep sea technologies, and the use of AI there offer a lot of potential great things. Also presents some challenges. You know, the economic impacts there can disrupt the marine ecosystem, biodiversity. Uh, there's a slow recovery. It may take decades or centuries to slow growth rates of some of the creatures. Unique environments. You know, if I mine near hydrothermal vents, we can harm species relying on these environments. And location, you know, you're dealing in
Okay.
different species, different habitats, and different ecosystems. But it's a
Ecosystem.
dynamic area, Sharif, where AI, and particularly advanced technologies, robotics, machine systems, and others are fueling growth and creating a lot of new job opportunities, particularly for people in the STEM role. And also a lot of opportunity for startup companies and professionals to really get into the marketplace and do things. So I hope this kind of helps as an introduction to your question.
Thank you, Lauren, to join
Mhm.
today's session. We are discussing about artificial intelligence. My questions to you: what are some specific applications of AI in deep sea technology?
And did you say deep sea technology?
Deep sea technology,
Deep sea.
underwater technology.
Okay. Um, underwater technology. Um, let's see. Um, deep sea technology. So, well, the one of the biggest concerns would be cleaning up the oceans. I mean, that's going to be major right now. Um, the plastics and there's still some of the oil, the leftover from some of the oil spills. So I would think that applying AI to some of that process would be extremely beneficial. What do you think?
Yeah, Professor David Smith.
Mm-hmm.
Dr. Sharif, thank you again. Yeah, no, applying the technology is going to be very beneficial in all different types, going well beyond just the ability to look at sustainability in there. And if I look at some of the key trends in the deep sea technology and its enablement by AI and other advanced tools, like we said before, things like robotics and vision systems and others, uh, it's really shaping our understanding of some of the ocean mysteries that we still don't understand. Like I said, we know a lot more about the moon and Mars than we do the deep water in our own planet. So the ocean is uh, often receives so much less attention. Deep sea technology will allow us to explore the hidden corners where darkness and extreme pressure and conditions prevail. I mean, the water pressure at depths are crushing. We have to use special materials and things to get there, but we have breakthroughs and submersibles that's helping us get there. We are beginning to see seafood observatories set up where the
Oh,
AI and advanced sensors and really the digitization of all our tools and the ability to run in many ways autonomously there without having to have crew members in some of these observatories is going to change how we can look at it. We're also seeing microbioreactors uh, beginning to be able to go and uh, take the biomass that often sinks to the bottom and actually pollutes some of the ocean floor, be able to use for energy production, to be able to use produce materials that can be fertilizer and things for others. We're also begin to look at some of it because we're studying some of these deep sea lives and seeing how to adapt it to conditions on the surface, particularly in healthcare, and see it. So the deep sea organs live in extreme conditions, again, high pressure, low temperature, no sunlight. But these adaptations we're seeing are contributing already to scientific and medical innovation and making some very important breakthroughs that we're beginning to just see now. And by studying these types of creatures, we gain insights into biological connectivity and the application. And there's just so many synergies we're seeing together with the biometric design, the AI, life detecting sensor technologies, uh, the use of robotics under extreme pressure uh, and with minimal visible feedback because of how dark it is in a lot of it. And it's helping us really enhance our structural designs, our energy efficiency, and our adaptability as we look at robotics and visions and touch systems and manipulation. And like I said earlier, with our deep sea mining and imaging, we're enabling wide scale exploration of some of the ocean floor. And we're seeing improvements in mineral field prediction software, guidance for remotely operated vehicles, and really the whole autonomous driving that we're seeing on the surface with our cars and trucks. That same technology is being enhanced to do more and more in the deep sea oceans and to be able to help us there. We're also, even on the surface, seeing that same type of AI and vision systems and robotics being used because we now have cargo ships with no human crew. They're all autonomous, driven by AI, driven by sensors, driven by vision systems and others. So this use is coming into wide play in our oceans around the world.
Thank you. Madam Lauren, you want to add any points?
Looks like we are reaching the lot, deeper depth, 10,900 meters in the Mariana Trench, the world's deepest point in the Western Ocean. So, if we're able to do that, then I would think that we're going to be accomplishing a lot with robotics and in under ocean exploration.
Okay.
So, yeah, and yeah, it looks like they've developed a couple of them and are really cleaning up the seas. So that's important too.
Thank you. My next question is to Professor David Smith. What challenges are associated with deploying AI in the deep sea environment, and how can these challenges be addressed? Professor David
Well,
Smith.
Sharif, your question's a great one, and it takes many parts as we look at how they can be addressed and saying, some of the challenges are how do we create an understanding of the impacts on it? And this is where we're seeing some of the regulations begin to come in place. Because even though this type of interfacing has immense potential for the global production of clean energy technology, it raises really questions and the challenges around environmental impact and how to regulate those. So there are some regulations that are already being put in place for that, Dr. Shreve, including one of them is called the United Nations Convention on the Laws of the Sea. And it established the objectives for the humankind's care of the seas. In 2023, there was another thing put in place, which is the International Seaboard Authority, which discusses really what rules should be put into place to govern things like deep ocean, deep sea mining, the extraction materials, the extraction of even things in the shallower water, particularly biomass and energy. And there's a a group that is trying to agree on a roadmap to be put in place to address these. And the roadmap aims to strike a balance between the research and understanding and using the technologies in deep sea commercial opportunities, scientific opportunities, and environmental protection. There's scientists estimate that some of the mineral deposits, including critical minerals, are much more abundant on the seafloor than on land. So you have to go back and strike a balance between those and how there can be done, because there's so much opportunity as we look at some of the current key trends we're seeing in these areas and how they can be used and how we can put in place. And Sharif, I'm going to jump ahead because I know you're going to ask me this question in just a little bit. But if you look at this approach to the deep sea technologies and the use of AI and robotics and the other systems, there's great opportunities in developing nations on this. If I look at just marine surveillance and ocean data harvesting, there's a German company called Plan Blue, which has developed an underwater satellite that is equipped with AI and machine learning. And this underwater satellite robot scans and maps large, uncharted areas of the ocean floor. It's hard to realize, but over half of the ocean floor has never been mapped, and it's in the process of doing that now. I've used the example, we have more detailed maps of Mars than we do of our own ocean floor. But this Plan Blue company is using advanced imaging capabilities to really get a clear picture of the impact and biodiversity. In Australia, there's a Hydrus autonomous underwater drone system that dives to depths of about 4,000 meters. And it locates and identifies new marine life forms. It monitors coral reefs and does that. You're also seeing other places in developing nations where it's coming into forefront. There is something called the Frontier Tech Hub, which has tailored a low-cost, easy-to-deploy deep-sea exploration system that is equipped with cameras, and it enables low to middle-income countries to really explore the deep sea. It's been tested in Scotland and in Belize and other places, and beginning to be deployed to many of the developing nations that border on the ocean. And you see, also, there is really for particularly developing nations, because we've talked before in your program, Sharif, about how many developing nations are developing science programs around space, while those same science programs around space have technology synergies with looking at deep ocean and deep ocean technology. We see them on how to look at propulsion on biometric surfaces. We see artificial intelligence, particularly artificial intelligence with cooperative networks, where we're leveraging all of it. We're looking at life detecting instrument design, because we're still discovering every year new life forms in our oceans that we've never seen before. And the other thing for developing countries, Sharif, is the ocean economy is developing and evolving in such ways that it's creating more of an economic development opportunity for these developing countries to create new industries, to create more job opportunities, to increase the GDP. And there's new data sets being involved that are perfectly applicable for developing nations. And looking and developing these new industries to be used. And so, Sharif, I hope that answered your question.
Yes, thank you. Madam Lauren, anything you want to add?
No, not at this time, I think. Just getting familiar with Plan Blue, and that you know, understand it.
Mhm.
Pretty amazing.
Um, and
AI-driven process and pipeline. And, just the audience, I'm sure they don't know exactly what's going on here, but seafloor mapping systems attached to underwater drones operated by scuba divers. Pretty amazing. Um,
mhm. Okay.
and that's,
Uh,
so it's not
Professor David Smith. Yeah.
highly expensive, but it's definitely highly efficient.
Let me make sure
Okay.
I'm unmuted. Yeah, Sharif, there's just so much that we can leverage here. There's so much we can do. You know, going back to one of your earlier questions on how AI really helps in ocean exploration, particularly the deep ocean, is we talked a little about autonomous underwater robots. Yeah, we really could not do those without the AI powered software, without the AI enhanced views of looking at sensors and sensor development. Uh, Earlier we talked about graphene. Graphene has a role in helping us build these underwater structures, these underwater vehicles and the underwater robots because of its high strength and its ability to be very flexible, which you need. For example, there's another instance where one of the vehicles that is being used in this is called NUAD Under Ice, NUI, and it utilizes an AI system called Spock, which I love the reference there. But this AI system in this autonomous underwater robot allows it to select areas along the seafloor for sampling. And just like humans learn from experience, these autonomous underwater robots using this type of AI and machine learning
Mhm.
and the ability to begin to build models based around it is allowing us to uh, train using vast amount of data for them. And it learns to explore, for example, Nuri learns to explore the ocean floor efficiently this way and identify new things. There's another place where we see AI just really very traditional in there. Traditional marine biologists study ocean uh, animals while they're diving, but the presence of divers in the water alter animal behavior. But some of the AI driven robots, and there's another one called Curie. I love it. It stands for Curious Robot for Underwater Exploration Experimentation. It's trained to identify fish, uh, jellyfish, other creatures, and other animals in coral reefs. And it does it uh, uh, by being minimally disruptive. So when an interesting animal appears, the AI inquiry allows it to follow them, and the robots then track the animals independently. And things like this really help us understand the coral reefs, the ecosystems, and the other things that are happening in the deeper ocean, really more comprehensive. I mentioned before things like mapping the ocean floor, and we do this not only to get an understanding of the topography, but we're using this to assess ocean health and identify areas that potentially need either more protection or remediation in place. And we see that. We also, though, know that the use of AI and the technologies we've been talking about can withstand harsh conditions, again, from extreme cold to high pressure and all those which are needed. The other place that we're seeing the use of AI and marine technologies and deep sea technologies is to explore sea ice in polar regions. We're seeing them now beginning to be deployed more and around submarine volcanoes. And we've seen with some recent underwater volcanoes eruptions, the use of robotics and AI and the visioning systems and others to actually be very close to them and understanding how different underwater eruptions are from eruptions on the surface. And again, we're seeing the same type of thing that we're seeing how AI and the robotics and the deep sea technology is really valuable data for research and conservation. And, it begins to let us begin to do more and more stuff. And again, we're going back to things like the International Seaboard Authority and Seabed Authority, I'm sorry, and how they are trying to do the balancing act between promoting the research to promoting commercial applications and letting us go back and make sure we do the delicate balance between those and the environmental impacts that we can cause there. So that's some of the other things that are happening in that area, Sheree.
Thank you. Madam Lauren, anything you want to add?
Okay, the ocean cleanup robot. Ocean cleanup deploys a growing network of interceptors. Rivers around the world, which together have removed over 17.7 million pounds of trash so far. Ocean cleanup currently has 14 interceptors in 7 countries. So, we're working on ways to clean up the oceans. I mean, I just think that's kind of number one in the priority list.
Mhm. Okay. Professor David Smith, can you mention some of the advancement and the disadvantage of this AI integrations in the deep sea tech or deep sea research?
Well, Sharif, again, great question. Some of the reasons for it is a lot of the ocean secrets really are places where it's very difficult to take humans to study and to be able to interact in that environment because, as we mentioned, as we go deeper and deeper in the ocean, we go to a place where there's no light. The pressures against the hulls will crush most vehicles. If I were to take a traditional submarine and take it down to these deep depths, they would be crushed without advances in material science and the other uh, uh, advances we're making. But the use of AI, the use of autonomous systems, the use of remote sensors, and remote robotics, and particularly fantastic development in the robotics arms that were actually a lot of it was pioneered by what we're doing in space applied to the deep oceans, but even the the robotics we're using in deep ocean are even more complicated to build than the ones we're deploying in space. So you begin to see that as we're doing things. The other places, Dr. Sharif, is we see some of the key players beginning to come out more and more. Uh, there, the Chinese are beginning to get very involved in some of the deep sea organization. And there's a Grudon laboratory that has been at the forefront of some of this. And they are looking at uh, particularly the new deep sea animals that are being done. And they're shifting to exploring ecosystems more. So they're, again, going back to the areas and looking at molecular biology technologies that AI and the deep sea are pushing to new frontages. You know, you heard me mention bioreactors. And in some of your earlier programs, uh, Dr. Sharif, we've spent time talking about the use of biomass and bioreactors in different ways and how it's done on the surface and the benefits of those being used all around the world, particularly in developing nations. Well, we're seeing the same type of things done underwater today and being able to take advantage of that and the unique minerals and other capabilities we're finding. And just like the terrestrial based biomass generators and bioreactors are being used to help create sustainable environments on the surface. We're going to see the same things deployed underwater in our oceans to do the same things. Um, I've talked about the precision seafloor mapping, but we're seeing companies that are really looking at uh, advancing technologies. We now have probably 50 companies that have come to play in just looking at the integration and deployment of AI and robotics and advanced sensor technologies and others um, for exploring the deep oceans. And, if I were to go back 10 years ago, I think I would probably be able to count on one hand the number of companies that were dedicated in those areas to doing that type of development. So for entrepreneurs who have some insights and interest in AI and robotics and material science and uh, really understanding a part of our world we don't understand well. There's some great entrepreneur activities that can be taken in here and great partnerships because most of the surface of the earth is underwater. So a lot of opportunities and a lot of places to begin to do that type of work.
Thank you. Madam Lauren, what's your closing remarks for today?
Okay, well, we've always got to look at the two sides of everything, and uh, what I'm looking at is that biomass is quite expensive, does require a lot of space, and still releases greenhouse gases. So just the other things to consider about biomass energy.
Thank you. Professor David Smith, what's your closing remarks for today?
Um,
In terms of aquatic biomass, of course. Yeah.
yeah, I agree. There's a lot of places you can look at this, and again, what we see is that the world of deep sea technology is one of a complex ecosystem, complex systems like we've talked about before, and one where a lot of areas are coming together to make this a frontier, a new type of frontier as we see that. If I go back and uh, look at what we have learned in our oceans, and even the last 5 years, we've had some remarkable strides made. The early 2000 wreck, we really witnessed some groundbreaking expeditions to the Earth. From the Titanic wreck and deeply understanding that to hyperthermal vents and others, and even into the deep trenches, scientists and explorers are going very much more into these uncharted territories. We see remotely operated vehicles and autonomous underwater vehicles really reach a new area of sophistication and a new area of capabilities, particularly for the deep ocean. And have become really essential tools for deep sea research, and the use of AI and the advanced systems, particularly imaging and sensors, are some of the enablers. We're also seeing these have helped us understand biodiversity and adaptability a lot more. So this deep sea ecosystem research enabled by this, we really see how creatures adapt to these extreme conditions like the bioluminescent fish, the giant tube worms, and the deep sea squids. These all, captures our imagination, but they also give us a deep insight of how we can do things to affect our health and to affect our adaptability. And these type of adaptations are actually inspiring some of our new innovations in robotics and material science as we look at the next generation of what we can do with our deep sea technology. And again, we have to go through the challenges of the environmental preservation of what's there, to look at the environmental impacts and all of that. But, we are seeing international regulations and collaborations begin to come together to address this. We also know that deep sea mining is an area that we have not done hardly any of, and it's an opportunity for commercial interactions, particularly with rare earth materials, which are really, we've gone through most of those that we can touch on the surface, but there's a balancing act there. And so if I look explicitly at AI, it has really revolutionized our ability to do things in this space. You know, it's AI-driven robots, as I said, help us map, help us study, help us monitor, and all of these are done without putting human beings in risk. And so the synergies we have between what we're doing in the deep seas, what we're doing in space, particularly as we began to look at developing habitats and new ways to autonomously study and go to Mars, go to Europa and other areas like that. There's this natural synergy and collaboration between them. And this synergy and collaboration is making itself available not just to the top tier countries, but to the developing countries as well, Dr. Sharif, you know. And, you know, we're in this exciting era where we're at the really the cusp of a deeper understanding of some of the ocean mysteries. And, you know, there's so much to do, but we need to understand on how to protect as well as understand these, you know, vast blue oceans that really shape our planet. When you look at our planet from deeper out in our solar system, it is a blue ball, and that blue ball is our oceans that we need to understand even deeper.
Mhm. Thank you, Professor David Smith, and thank you, Madam Lauren, for joining today's sessions. This is excellent contribution for this kind of new topic. Thank you, bye-bye, and take care. I request all of our audience, please share our content as much as possible with the government agency, corporation, and academia. Thank you, bye-bye, and take care.
Bye-bye.
Thank you.
Bye.